In this video, I'm going to introduce the intermediate value theorem and how to apply the theorem to solve a problem. When we apply the intermediate value theorem, we should be very careful about two conditions. One is the function is continuous and it's defined on a closed interval, a and b. So if you pick any number, say k, between fa and fb, then we can find a number c between a and b such that fc is equal to k. Here is the picture explaining the intermediate value theorem. So when x is equal to a, there's a corresponding y value fa in here. And when x is equal to b, corresponding y value fb is here. And if you pick any number, okay, say k, between fa and fb, okay, then there is a corresponding x value c between a and b. So this is the intermediate value theorem. So how to apply this theorem to solve a problem? Here's the problem. We want to show that there exists some number c between 0 and pi such that the 1 minus tangent c is equal to 0. First, you need to recognize that this problem is an application of the intermediate value theorem. Well, to apply the intermediate value theorem, you need to consider some function which may be continuous on this closed interval. Okay. Because you want to show that the 1 minus tangent c is equal to 0. So you may want to consider function fx is like 1 minus tangent x. Okay. And then you want to apply the intermediate value theorem, okay, to this function, okay, to show the existence of a root of fx. So if this function has a root between 0 and pi, okay, so fc is equal to 1 minus c, tangent c, then we're done. But the problem is that the fx actually is not continuous on the interval 0 and pi. Because you know that the tangent is not defined when x is equal to pi over 2. And another problem is that when you plug a 0, okay, then you have 1. Because tangent 0 is equal to 1, so f0 is equal to 1, which is a positive. And you may want to have f pi is equal to negative so that you can apply the intermediate value theorem. But unfortunately, f pi is equal to 1 minus tangent pi. Tangent pi is equal to 0. So that's 0, that's 1, still positive. So you have both problems actually to apply the intermediate value theorem. Oh no. So you may be very frustrated as it appears that the intermediate value theorem cannot be applied. But don't worry. We know that this function is continuous, okay, on some closed interval, okay, between 0 and a for any positive constant a which is less than pi over 2, because tangent x is continuous between 0 and pi over 2. And another thing is that as x approaches pi over 2 from the left, okay, which means that the x is less than pi over 2, then tangent x goes to infinity. What does this mean? This means that if x is close to pi over 2, then tangent x can be very large, actually as much as you want. So by part 2, we can find some number b between 0 and pi over 2 such that tangent b is greater or equal to 2. Actually much bigger than that one, but anyway, at least to 2. So we can say that fb is equal to 1 minus tangent b, because tangent b is equal to bigger than and equal to 2, so this is negative. We have the information f0 is equal to 1, which is positive, and fb is negative. And we know that the function f, by part 1, the function fx is continuous on the interval 0 and b. But the interval 0 and b, closed interval 0 and b, actually included in 0 and pi. Actually, b is much less than pi, because b is actually less than pi over 2. Okay, so now we are ready to apply the intermediate value theorem. Okay, then there exists some c between 0 and b, okay, such that fc is equal to 0. Thank you for watching.